display we're seeing here in the middle of the screen is an oscilloscope display. An oscilloscope is a type of instrument we often see on a heart monitor. It displays how something is changing as a function of time. Both bright dots moving across the display in this case are showing the variation in barometric pressure as a function of time. The sensor connected to the lower dot is located in an upstairs bedroom of Norma and Ron Schmidt's house. The upper sensor is located in the kitchen where the instruments are located. The home is in Underwood, Ontario. The house is located about 500 meters from the closest wind turbine. What we're seeing here is the fluctuation in the barometric pressure in the home, which is occurring at a frequency identical to the blade passing frequency of the turbines in the immediate area of the home. This blade passing frequency is 0.72 Hz, or 0.72 cycles per second, far below a frequency that humans perceive as sound, but well within the sensitivity of our eardrums or tympanic membrane, as it is known medically. This variation in barometric pressure is a very small fluctuation relative to the barometric pressure itself, but has a sound pressure level somewhat louder than loud speech at a distance of about 2 feet from a person speaking. This level is about 60 to 65 decibels on average, but reaches much higher and much lower levels over a period of time, as we can see from the oscilloscope display. The display is calibrated in pascals. Each centimeter is about 0.1 pascal. The pressure signals have been filtered such that only the fundamental blade passing frequency is shown. There are 5 or 6 significant harmonics also present in the home, but have been filtered to improve the visibility of the fundamental pressure fluctuation. As the barometric pressure rises, the position of the bright dot moves upwards on the screen. As the barometric pressure drops, the dot moves downwards. The up and down cycling of these dots shows that the pressure is cycling up and down. This slide shows precisely the same phenomenon in a different home in Port Elgin, Ontario. There is just one turbine in Port Elgin, which is much smaller than the turbines in Underwood, about 0.5 megawatts versus 1.7 megawatt turbines in Underwood. The turbine in Port Elgin rotates at about twice the RPM as the larger turbines, generating blade passing frequencies of approximately 1.4 Hz or 1.4 cycles per second. The display shows the higher frequency as more rapid fluctuations in the barometric pressure on both sensors. The actual magnitude of the pressure fluctuations in Barb Lowe's home is lower than in Norma's home. Barb's home is located over 2 kilometers from the small turbine in Port Elgin, but is also located up on a hill with an essentially unobstructed view of the turbine. A second factor we believe may be a significant contributor to the relatively high infrasound level in the home is the location of a water tower behind Barb's house. The water tower is positioned such that reflections of the pressure waves from the turbine off the water tower will arrive at Barb's house at about the same instant the pressure waves will arrive directly from the turbine. This causes the pressures to add together, resulting in an increase in the pressure fluctuations in the home. The pressure waves are expected to be highest at Barb's home with a southeasterly wind.